Hey, Science 10s. This is lesson CB4, so chemistry, fourth lesson in chemistry B, types of chemical reactions. So make sure you find your way to that. Have your periodic table out and maybe some scrap paper just because you might need it. And let's get going. So we're going to talk about kind of 5 basic reactions that you will see um, in high school chemistry. So one of the first ones that we're going to look at is called a formation reaction. It's also sometimes called a synthesis reaction. RXN is just a lazy way of writing reaction. Um, One other thing is with today's stuff, it's gone up to this point in chemistry that if you don't understand the last one, the next one's a little bit difficult. If you don't understand some of those previous topics, you need to get a grasp on it. So you need to be sending me an email if you found you were struggling with balancing, or if when you got some of those marks back, you found you were not good at naming ionic compounds. We need to get you watching some videos and figuring out those pieces of information, because if you can't balance a reaction, if you can't write a formula from a name, from here forward is going to be almost impossible to get questions right. So just make sure if there are some of those things that you're really still struggling with, talk to me. Let's figure it out. So a formation reaction or a synthesis reaction, if you're thinking of forming something, you're making something new. And what it is, you're producing something that's more complex. So kind of our general form for this is whatever A is plus whatever B is. So an element plus an element producing a compound. So instead of having them separately, now I have them bonded together in some type of compound. So I always use really terrible analogies that I know would offend all of you. So the first one, for a formation reaction, I have two individuals. So a boy and a girl, or a boy and a boy, or a girl and a girl, and they're separate, and then they become a couple. So they get together, and now they're a couple, and they're one of those terrible couples that spend all their time together, and you can never get your friend back because they're always with their couple. So it's two separate things coming together to make one thing. So a single, a couple. So an example that we have here is the formation of iron 2 oxide. And so that's taking solid iron in the presence of oxygen to produce iron 2 oxide. And so what we see is we also have a balanced reaction. So they have coefficients in front, 4 iron in, 4 iron out. 6 oxygen in, 2 times 3 is 6 oxygen out. So what this actually is, what this compound is rust. So on an older car or a new car that's had some trouble, when the iron in kind of the outside of the vehicle is exposed to oxygen, usually it requires some humidity or moisture in the air to kind of facilitate this process. It produces iron 2 oxide. Sorry, iron 3 oxide it would be, because oxygen is A2 minus, so this needs to be iron 3 oxide. Next one is producing simpler substances. So this is called a decomposition reaction. So it's breaking something down into more simple things. Decomposition reaction. And so again, it's producing simpler substances. It's breaking things down. And so in our general form, it's taking something that's a compound and splitting it into its elements. So if we're going to use my terrible examples again, this is a bad breakup. So we have our couple from up here. They're always together. They have a disagreement over what's the best, I can't even think of anything, my brain is so mush. What's the best type of sandwich? And they have a breakup and now they're separate again. So they broke up. They're no longer this couple, this two thing. They've broken up into their individual pieces. So the real example that we have, instead of my terrible examples, is breaking down magnesium oxide. So this is magnesium oxide into solid magnesium and oxygen gas. So again, a balanced reaction. It's magnesium oxide, our reaction arrow here. So since it's going from something complex to two simpler things, that's a decomposition reaction. Next one. There we go. So number 3, for the next ones, we're going to talk about replacement reactions. So this is called a single replacement reaction. And so what we see there is it's exchanging components and it ends up being not more or less complex. So what we're doing in kind of our general form here, we're having something that's a compound and something that's an element, something that's alone and something that's in a compound. And what we see is our reaction creates a new compound and a new thing that's by itself. So what's actually happened is this B in my general form has been exchanged for whatever this C is. And so we see now we have a new compound that we didn't have before the reaction, and we have a new element that's by itself. So to continue on my terrible examples, I always say that this one is like a mistress. So here's a couple, here's the mistress, and the whoever individual A is leaves their spouse to be with the mistress. So now these two are a couple and this is a single. I can't see you guys right now to know how offended you are by my terrible example, but I find that usually it gives you a little bit of an idea what I mean by what's happening here. So here we have silver nitrate. So AgNO3 is silver nitrate, and we have zinc on its own. So this is taking a silver nitrate solution and just putting a piece of solid zinc in it. This is a reaction that I can actually do at school because I have both of these things and I actually usually do it. And so after our reaction here, what we see is we have a new compound. So now we have zinc nitrate, which we didn't have on this side. We had zinc on its own. We had nitrate in a compound with silver. And now what we have is we produce solid silver as well. So the important thing with these in replacement reactions, we need to have the same things replacing each other. So in that silver nitrate one, remember that silver nitrate in that compound, what it's made up of is Ag plus and NO3 1 minus. Because again, nitrate always forms a 1 minus, silver will form a 1 plus. So we need to think about our other element. So this is zinc. So looking at zinc and what kind of, I just spilled stuff all over the place. What kind of ion zinc can form? It can form a 2 plus ion. So right now, again, we know it has no charge, but when it's going into a compound, it will form its ion species. So we know that cations and cations want to exchange. So we want to exchange this zinc with this silver to form, in the end, zinc nitrate. Sorry, I can't really fit it on there. So we wouldn't be able to form something like silver zinc. If you can hear lots of weird noises, my child is driving around on a little push car right above my head on the floor upstairs. It's so loud. So we couldn't have something like this forming because we don't want to have two things that have positive charges. So this couldn't be our new compound. So we know that zinc is going to be replacing the cation that is in the compound. So it's going to be replacing the silver. And so that's what it's saying in this box here. So cations or positive ions will replace cations and anions will replace anions. And again, this is because the attraction of opposite charges will create a neutral compound. So you can't have two things that are positive or two things that are negative. So that's something to keep in mind. So exchanging components is the big part. It's not more or less complex. We have a compound and an element after we have a compound and an element, but they're different compounds and elements. Question or number 4 here is called a double replacement reaction. So what's happening in our double replacement reaction is we have 2 compounds before, and after we are still going to have 2 compounds. But they're 2 different compounds. So AB plus CD produces AD plus CB. So my continued example, this is a swingers party. So A and B show up together, C and D show up together, and they both leave with a new friend. So A is with D and C is with B. So again, this is a replacement reaction. So where we're seeing the anion of one compound exchanging for the anion of another compound, or cations exchanging for cations. So our example here is aluminum chloride plus sodium hydroxide produces aluminum hydroxide and sodium chloride. So again, I'm doing that really quick, but you should be able to name all of those compounds right away or pretty quickly. These are all ionic compounds in this case. So aluminum chloride, sodium hydroxide, aluminum hydroxide, sodium chloride. Again, when you're naming ionic compounds, you don't really pay attention to those subscripts there. That's only for molecular compounds where you use them in the nomenclature. But let's just think about what everything represents here. So aluminum forms a 3 plus, chlorine forms a 1 minus. That's why there needs to be 3 Cls to balance out the charges of the 3 positive. So that's in this compound. In this compound, so sodium forms a 1 plus, hydroxide is a polyatomic that forms a 1 minus. Nice 1-to-1 ratio there. Again, sorry, that's supposed to say 3 positive. It's super hard to write small enough. So Al3 plus, OH1 negative, that's why there needs to be 3 of the hydroxide, and sodium forms a 1 plus, chlorine forms a 1 minus for the chloride ion. So just kind of looking at this side of the equation, we know a positive with a negative and a positive with a negative. So if we are going to have a replacement reaction, we need this positive to end up with the other negative. So we can't have aluminum ending up with sodium. We already have this compound, so if we want something new, we need it to end up with the other negative. So that's how we end up with what's on this side of the reaction. Aluminum needs to end up with hydroxide, so Al3 plus, OH negative, and sodium needs to end up with chlorine. We'll talk about this a little bit more in CB5. I'm getting a little bit ahead of where I kind of needed to be, but we will talk about predicting products a little bit more after. But what we see is, since we have 2 complex compounds and we end with 2 complex compounds and they've switched their pairings, we know that that's a double replacement reaction. And then the last one that we'll kind of talk about is combustion reactions. So it's a chemical reaction of a substance with oxygen. Most of what I'm going to talk about is mostly hydrocarbon combustion questions. So these are often described as burning in the presence of. Often involves a hydrocarbon fuel. So hydrocarbon means it has hydrogen and carbons within it. It might have other stuff as well. So such as methane or ethanol. So again, methane is CH4. That's natural gas, what's going through your furnace if you're heated by natural gas in your home. Some houses are heated by electric or by water. Ethanol, CH3, oh no, that's methanol. C2, sorry. Ethanol is C2H5OH, isn't it? Yeah, C2H5OH. I think that's right. Hopefully I'm not messing that up. That's what's in, it's one of the primary parts, additive-wise, of gasoline. So ethanol blended gasoline, you've probably heard that. I think Shell's a big one that does that. So a fuel for vehicles. So another part of gasoline is octane, so C8H18. You don't need to know about that. But this is what's happening within the engine of a car. So C8H18, again, you don't need to know that that's octane, but it's giving you a chemical formula. So it's saying a hydrocarbon plus oxygen. Again, some of you guys are getting really good at this, that oxygen when it's on its own is found diatomically. So O2, oxygen on its own. Sorry, I wish I could shut that off. So a hydrocarbon plus oxygen produces CO2, which is carbon dioxide, and water. This is water vapor, right? It's water as a gas. The other thing that comes out of this is thermal energy, so heat energy, and that heat energy is important. So that's our general formula, that something for a hydrocarbon plus oxygen produces carbon dioxide and water. Again, these are a little bit of a pain to balance. We talked about that already, that they're a little bit of pain to balance, but sorry, that's our general form for it. So burning hydrocarbons will always produce carbon dioxide and water. These ones as well, so the next one, here it says reaction of a substance with oxygen. Sometimes these ones are classified as combustion. I 99% of the time would say that this is actually a formation reaction because we have iron plus oxygen produces iron oxide, should be iron 3 oxide, which is rust. So sometimes this will be called a combustion reaction because, again, it's something reacting in the presence of oxygen to produce a new compound. I'm really going to be focusing on hydrocarbon combustions that have this general form right here. A hydrocarbon, sometimes you'll see it written as CXHY, meaning like there can be any number of carbons or hydrogens, produces O2, produces carbon dioxide plus water. So that's the hydrocarbon combustion. So I think on the top of your next page, it probably says go back to the balancing skeleton equations. So that's CB3. Go back over it and see if you can classify each of the reactions as one of the types there. So either a formation reaction, a decomposition reaction, a single replacement reaction, a double replacement reaction, or a combustion reaction. So there are some questions on the next page, though, that are pretty important to see. So it says convert the following chemical equations to balanced chemical equations. And then it should also say, and determine the type of reaction. So, and determine reaction type. So ammonia gas combines with oxygen gas to form nitrogen gas and liquid water. So this is what's called reaction. I'm not thinking of the right words that I want here. I don't want to call it a word equation because it isn't yet. We'll convert it to a word equation. So we have just the words of it now. So ammonia gas combines with, so words like combines with means plus, to form, that means arrow. The words and mean plus. So we want to convert it from a sentence to a word equation to start. So I'm going to take this into lots of steps, and I know you probably don't have room. There's not a lot of room on that page, but I'm going to write it ammonia plus oxygen produces nitrogen plus water. So I've just kind of summarized this a little bit more in terms of what the equation will actually look like. So ammonia is one of your memorized molecular compounds. So it's NH3 plus oxygen. We know oxygen is found diatomically, so that's going to be O2. We could be writing states for all of these. So gas, gas. To form nitrogen gas. Nitrogen is also found diatomically, something you need to remember. And water, liquid water, so H2O, liquid as our state. So right now, what we see is thinking about those 5 reaction types. What type of reaction does this look like? So we have a compound and an element producing an element and a compound. So this is a single replacement. The other thing that we need is to balance this equation. So right now it is not balanced. So we need to make sure that we have a balanced equation in the end. So you might make yourself a little chart there. So your in-out chart. So we have nitrogen, hydrogen, and oxygen. Again, you definitely don't have room for all of this in that little space. You might be doing this on your own paper. You might just write your final answer and be paying attention. So right now we have 1 nitrogen in. We have 2 nitrogens out. We have 3 hydrogens in. We have 2 hydrogens out. We have 2 oxygens in and 1 oxygen out. So right now nothing's balanced. This one's a little bit of a process to try to balance. So let's start out with our nitrogen. So we have 2 coming out, only 1 going in. I'm going to write a 2 here. So that changes this to 2. But it also changed, so 2 times 3, now we have 6 hydrogens coming out. Or sorry, 6 hydrogens going in. So in order to balance that, I know I need to write a 3 here. But what that did is it changed my oxygens coming out as well. So now this is a 3 coming out. So we get to one of those problems. We often see this with hydrocarbon combustions where we have 3 coming out, we have 2 going in, but there is no number that I can put here to make this equal to 3. I would need to put 1.5. You can't put a fractional coefficient in, so you can't put 1.5 here. So when you get to this problem, it's often with hydrocarbon combustions, what you need to do is double everything that you've done so far. So we're going to change this now to a 4, which makes this a 4. And we're going to have to do this. So there was a 1 there before, so if I'm doubling it, that's going to make that a 4. Looking at our hydrogens, so we have now 12 going in. So we need to double this one as well, right? So to make this 12, we need to have a 6 here. So let's figure out what that did to our oxygens. 6 times 1 is 6. So now we can put a 3 here because 3 times 2 is 6. So this one's a little bit of a pain to try to balance, but seeing that one point where we couldn't put a 1.5 there, you may not do that. So what you need to do is double all of your other coefficients and then you'll be able to fix it up. So double checking. So 4 nitrogen in, 4 nitrogen out. 4 times 3 is 12 hydrogen in. 6 times 2 is 12 hydrogen out. 3 times 2 is 6 oxygen in. 6 times 1 is 6 oxygen out. So that balances with coefficients of 4, 3, 2, and 6. So that's our balanced chemical reaction. And again, we identified it as a single replacement reaction. So methane gas burns to produce carbon dioxide gas and water vapor. So methane gas, again, methane is one of our memorized ones. So CH4. Gas produces carbon dioxide gas and water vapor. So vapor meaning gas. So the one thing that it doesn't really tell you is that it's going to burn in the presence of oxygen. So the way that you would know that, again, is because methane is a hydrocarbon. We're producing carbon dioxide and water vapor. So in order to have these oxygens coming out, we need to have oxygen going into the equation, right? There's no oxygen in methane. So we couldn't produce carbon dioxide and water unless there was oxygen present. So our reaction type, this is a hydrocarbon combustion. And again, some of those key features is oxygen plus a hydrocarbon produces carbon dioxide and water. So balancing, so looking right now, we have one carbon in, one carbon out, 4 hydrogen in, 2 hydrogen out, 2 oxygen in, 2 plus 1 is 3 oxygen out. So remember when balancing these, the tip that I gave you in the last one is use echo. So do everything else. In this case, there's nothing else, so we don't need to worry about that. Then balance your carbon, then balance hydrogen, then balance oxygen. So carbon's balanced. So we've done E in theory. We've done C. Let's look at hydrogen. So 4 hydrogen in, 2 out. So we need to put a 2 here to balance it. That fixes this, but that also modified this oxygen. So again, we have 2 oxygen here. 2 times 1 is another 2. So now we have 4 oxygen coming out. So in order to make this equal to 4, we need to put a 2 here to make this equal to 4. So again, double checking, 1 carbon in, 1 carbon out, 4 hydrogen in. Again, remember that there's always a 1 there if you don't see it. So 1 times 4 is 4 hydrogen in, 2 times 2 is 4 hydrogen out. I didn't change that in my chart. 4 oxygen in, 2 plus 2 is 4 oxygen out. So that balances with coefficients of 1, 2, 1, 2. And again, the reaction type is hydrocarbon combustion. Next one, so solid copper 2 oxide is decomposed into its elements. So again, it's giving us a reaction sentence. We need to turn it into our word equation, and from there, turn it into our overall equation. So copper 2 oxide. This 2 indicates that it's copper with a 2 plus charge. We know oxygen forms a 2 minus charge. So overall copper oxide, copper 2 oxide, is going to be CuO decomposed into its elements. So it's saying decomposed, decomposition broken down. So what would its elements be? Well, its elements would be copper, and its elements would be oxygen. Oxygen is found diatomically. This is where you'll get messed up. Again, as I mentioned, if some of those things from chemistry A weren't clicking, or even the balancing from chemistry B, this portion is going to be very, very difficult for you. So please reach out if you need some help. Again, I've given you feedback on everything that I've got so far from chemistry A. So you need to be looking over those worksheets that I've marked and understand what your mistakes are, because if you just keep making the same mistakes, that's not the best. So sorry, I should be writing states. Solid copper 2 oxide is decomposed. So again, our reaction arrow here. So this one's pretty obvious for reaction type because it has the word decomposed here. So it's a decomposition. So as far as balancing, I know a couple of you guys probably have started to ditch the little in-out charts. That's fine if you feel confident in your abilities. I can balance them without it, but if you need to keep making a chart, please do it because it'll help you organize yourself. So copper, oxygen, 1 in, 1 out, 1 in, 2 out. So our oxygen is what's out of balance. I'll put a 2 here. That changed our number of copper going in. So now I need to put a 2 here. So that balances again with coefficients of 2, 2, 1. So decomposition reaction. I think I will do, actually, maybe you want to try pausing it and try those next 3. They're a little bit more difficult. So again, you need to maybe just try the next 2. Actually, the last one's a little bit weird. You can try balancing them out and writing the reactions properly. So give it a pause and give that a try. So hopefully you've given it a shot now. So a magnesium hydroxide solution is reacted with a solution of nitric acid to produce aqueous magnesium nitrate and liquid water. So this one is getting a little bit more complex. Magnesium hydroxide is reacted with, so that's saying plus, a solution of nitric acid. So again, in CB1, we did acid nomenclature. So nitric acid, oh, I'm not writing, I'm just going to write the words first, to produce magnesium nitrate. And water. So again, you don't have to do this step from the sentence. So you can be given the sentence. It might be helpful though to kind of draw out all of the steps and make sure you're doing everything right. So magnesium hydroxide, magnesium forms a 2+ charge, hydroxide forms a 1-. Nitric acid, so that's HNO3. So again, coming from nitrate here, gives us nitric, magnesium nitrate, sorry. So magnesium forms a 2+, nitrate forms a 1-. Sorry, I should have been doing that here. And water. I'm going to write water as H+ and OH-. Remember, I've said before, if you have something with hydroxide on one side of your equation, sometimes it helps to write water as HOH instead of H2O. So now trying to write our actual formulas. So we know we have 2 positives contributed by magnesium, so that means I need 2 hydroxides to contribute 2 negatives. So our formula is Mg. And then for polyatomics, make sure you write brackets around it if you have more than one. You don't want to be writing, because that only applies the 2 to the hydrogen here, not to the whole hydroxide. So that's not correct if you write it that way. So brackets around it, and a 2. Nitric acid, I already wrote that, unfortunately, HNO3. Produces magnesium nitrate. Again, 2 positives contributed by magnesium, only 1 by nitrate, so I need 2 of the nitrates. And water, I'm just going to write as HOH down here. So looking at our types of reaction, sorry, I just need to cough. Sorry. So looking at it, so we have a compound and a compound producing a different compound and a different compound. So that's going to be our double replacement reaction. Sorry, I didn't put a space in there. Double replacement reaction. So now thinking about balancing this, so we need to have it balanced. Again, when we have something with polyatomic ions like we do here, it's usually so much easier to balance polyatomics as like a single thing. So instead of separating O and H here, I'm going to write OH. Oh my goodness. So right now, 1 magnesium in, 1 magnesium out. Good. Hydroxide. So I have 2 going in. I only have, again, hydroxide is just right there, 1 coming out. So 2 going in, 1 coming out. Hydrogen, again, I'm not worrying about this hydrogen because I'm counting this polyatomic hydroxide as one thing. So I have 1 hydrogen in, 1 hydrogen out. And nitrate, I have 1 nitrate in, 2 nitrates out. So thinking about how to balance this, so starting maybe with this hydroxide, since it's out of balance, I'm going to put a 2 here. So that fixes our hydroxide, but it changes my number of hydrogen. So now I have 2 hydrogen. Oh, I wrote that in the wrong spot. This should still be 1. This should be a 2. So now this is, I have 1 hydrogen coming or going in, 2 coming out. So I need to fix that. So I am going to make it a 2 by putting a 2 here. But what that's also done is changed my nitrate coming out. Sorry, my nitrate going in, which actually fixed it, which is awesome. So 1 magnesium in, 1 out. 2 hydroxides in, 2 hydroxides out. 2 hydrogen in, 2 hydrogen out. 2 nitrate in, 2 nitrate out. So good. That's our balanced reaction. So that balances with coefficients of 1, 2, 1, 2. And the last one, or the next one here, so solid iron 3 sulfide reacts with gaseous hydrogen chloride to form iron 3 chloride and hydrogen sulfide gas. Holy moly, lots here. So again, I'm going to do that extra step. So iron 3 sulfide reacts with gaseous hydrogen chloride to produce iron 3 chloride. And hydrogen sulfide gas. All right, so iron, it's telling us again, this 3 here indicates that it's iron 3. Sulfide forms A2 minus. Hydrogen forms a 1 plus. Chlorine forms a 1 minus. And hydrogen sulfide, again, that's one of our memorized moleculars. Or I guess you could do it as an ionic compound too. That makes more sense. So hydrogen forms a 1 plus, sulfur forms a 2 minus. So you need to have 2 positive charges to balance out the 2 negative charges there. So once we've done this step, now trying to write our actual chemical equation for it. So 3 positive, 2 negative. So we know we're going to need Fe2S3. So 2 times 3 plus is 6 positive. 2 negative times 3 is 6. Sorry, did I say negative on the other side? I'm losing it. So 6 positive, 6 negative. This will balance with a 1-to-1. Sorry. So we know we have 3 positive, 1 negative, so I need 3 negatives instead. So FeCl3. So looking at that, so a compound plus a compound produces a different compound plus a different compound. That's our double replacement reaction. Finally, balancing. So if you make your full chart, I'm just going to go through this because this is already 41 minutes long. So I'm going to do it quick. Double check if you didn't balance it the same. You may have made a mistake. Ooh, I don't have much room here. So it balances with coefficients of 1, 6, 2, 3. The last one, I'm just going to write it out. So compare it with what you've done. If you haven't done it, give it a shot. So 2HNO3, so that's nitric acid, dissolved in water. Reacts with solid. So the hard part, this dissolved in water, that's just indicating aqueous. If you try to put water as one of your reactants, I don't like this question, that's why I'm doing it really quick. If you try to put water as one of your reactants, you're going to have a real tough time trying to make things balance. So reacts with solid sodium carbonate to produce, to form liquid water. So in this case, it's saying we're forming liquid water, carbon dioxide gas, and sodium nitrate. Sorry for the balancing, there should be a 2 here as well. So this one really doesn't follow the pattern exactly of any of the 5 reaction types that we've already talked about. You'll come across some that are other, so they don't fit a formation, they don't fit a combustion reaction or anything like that. So you can sometimes call those ones other types of reactions. So it doesn't match any of the 5 reaction types. So there's not really an assignment for CB4. What you can do though is go back to your CB3 assignment and just classify each of the reactions as one of the types. So whether it's a formation reaction or synthesis reaction, decomposition, if it's a single replacement, a double replacement, or some type of combustion, probably a hydrocarbon combustion. So classify all of those. You'll probably be ready to go on to CB5 pretty quick. I've already started to talk about some of the stuff in CB5. So we'll see you then.